you might be saying to yourself, okay, sure, 10-5 counting. What grade are we in? Okay? But we're going to do this algebraically. This isn't the same counting that you've been doing since preschool or earlier maybe. Students, you just wrote down the definition of the fundamental counting principle. And I'm going to, I'll read it out loud, and it will sound a little confusing, but I'm going to do something that will help you get it down. If an event M can occur in M ways, it is followed by event N that can occur N ways. Then the event M, followed by event N, can occur M times N ways. Now, what would make that even more confusing for you would be if you'd had them both capital M's or both lowercase. So look and see, is your M and N for the events capital M's and N's? So you should have the events. Oops. Your events. Ew. M. N. Okay. Then this is number. Lowercase m. Lowercase n. So if you haven't had them be uppercase and lowercase, they need to be. There's a difference. There's a difference. And I also want you to write off to the right, if you have room for it, M times N equals number of outcomes. And you're going to put a square around that so you remember that. One of those things you have to memorize. That's something you should memorize. And also you're going to put a star at the top. That says first things first on the realist. No, actually it's first thing to do is ID the events. First thing to do is ID the events, even though ID is short for identification, and it's one word. Yes, sir. No. Thank you for asking, though. Events M and blah, 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 blah. Okay. Did you guys get this thing here? Anybody not get that? Let me rephrase. Good. Breadco's current options for sandwiches are, for sandwiches, you have meat options that are chicken, tuna, and vegetable. Now, somebody's like, well, vegetable isn't a meat. Well, it's a meat option, not a meat. So the lack of meat as an option is vegetable. The choice of bagels are plain or onion bagels. How many sandwiches are there? So what's the first thing that I have to do? Yeah.
You have to find the amount of outcomes.
That's the goal.
No, you have to find it.
What's the first thing I have to do? Stubby. ID the events. Exactly. Where did you get that information?
The top of the page.
Beautiful. Top of the page. It even has a star next to it. Okay? It even has a star next to it. It's right there. The first thing that I have to do is identify the events. So I'm going to write this down. Event M. Then I'm going to put a lowercase m. Event n. Lowercase n. So what is event m? The first thing that's happening as far as choices go. Yes?
It's
Meet options. And as my definition of the fundamental count principle goes, it says event m, capital M, can happen the lowercase n amount of times. So how many choices are there, Caitlin, for meat options? 3. You have chicken, tuna, and vegetable. We have 3 choices. How about event N, Webb?
The bagels.
Bagels. Bagel options, right? That doesn't seem right. No. Bagel option. And there are 2 of those. You can do the plain or the onion. I love everything bagels.
They look weird.
Oops. So we are going to create a tree diagram. I messed up with the layout apparently when I was printing this up, and I didn't leave room for you to write the definition of a tree diagram. So we're just going to make one. A tree diagram is called a tree diagram because it's an upside down tree. It starts at one branch and goes further out. So in order to do this, I'm going to say that my options for sandwiches, it says that my event M is 3 options. 1, 2, 3. Those 3 options are chicken, tuna, and veggie. And I'm also going to point at this and be like, oh my gosh, event M. And if I wanted a chicken sandwich on a bagel, how many choices of type of bagel do I have? Is that Bella? There are 2 choices. So I have 2 choices here. I have plain or onion. But what about the tuna? How many choices do I have if I wanted the tuna sandwich with a bagel?
2.
Okay. Schneider, what do you think?
2.
There are 2 of them also. All right, all right. And then with my vegetable, if I found a different way of having my protein and stuff, right, and fats. What choices, if someone wanted vegetable, how many choices do they have? Yeah. 2 choices as well. We're not leaving the vegetarians out. Sorry, don't mean to disappoint some of you. So we have, this is event N. Capital N. So look at the bottom of our tree, or if you wanted to consider it, the top of our tree. How many choices of sandwiches, like how many people could go into that sandwich shop or bread co. and have a different sandwich? How many? 8 times? I'm going to disagree with you, and I'll show you why. Yeah. 6. There are 6 of them. We have 1, 2, 3, 4, 5, 6. So one person has the onion bagel, vegetable option sandwich. One person has the plain vegetable sandwich. Someone has an onion tuna sandwich. Okay? So there are 6 of them. So I'm just going to write 6 and I'm done, right? No, absolutely not. We are not done. We are not done. First off, we have to make sure that we're answering the question being asked. Yes? Yes. We have to make sure we're answering the question being asked. What is the question being asked? Well, how many sandwiches are possible? And we just found out that there are 6 possible sandwiches. Six possible different sandwiches. So that's the answer for number 1. All right, so that's a tree diagram. Each event you have to have as an individual, and you go off from there. Yes, sir?
Can't you just multiply the m by the n? I mean, just like the... Yeah,
So,
m by the n.
okay, Joe wants to multiply the m by the n, and I would do 3 times 2, and that would equal 6. You are correct. And that's also exactly what you guys wrote right here.
Yeah, because I remember doing that in the question.
That's a bad hand. Whatever. Hands are hard to do. So that is the m times n equals the amount of choices. So let's do this. Let's make another diagram from this. Example 1. The bagel makes 9 types of bagels and has 10 flavors of cream cheese. Sweet. They wanted to advertise the number of different bagel and with cream cheese combinations that are possible. How many different possible choices are there? Let's do it. Let's make a 90 option tree diagram, right?
Yeah.
I really don't want to be here until 5 p.m., so no.
Let's do it.
So first thing we have to do is we have to identify the events so we don't make any silly mistakes, and also so we know what we're dealing with here. Don't take any shortcuts. Capital. Oops. My first event that is happening is what, James? I don't no numbers, but yes, bagels. The bagel choice. And as James just said, 9. There are 9 types of bagels. Next we have a second event. Mandrew, what's that one?
That is the flavors of cream cheese.
Oh yeah. And there are 10 of those. So I have my m multiplied by n equals the number of choices. I just need to substitute those in there. So I have my lowercase m, which is going to be 9. I have my lowercase n, which is going to be 10. And there are 90. And I'm going to rewrite it so it's answering the question that they're asking, because when there's words in the question, there must be what?
Words in the answer.
Beautiful. Wow, it's like we rehearsed that. Nice. 90 possible choices or combinations, I guess. So that means that 90 people could have something different than the other. So if you, yes.
But wouldn't there be 109? Because what if I just wanted to buy some cream cheese and just a bagel?
This is, if it was just cream cheese and just a bagel, that would not be a combination.
That'll be weird if you just kind of let it by anything else.
Well, that.
Spit out like ice
Maybe
cream.
a handmade some bagels.
Question? Yes? Shh, quiet. Quiet, Lexi. Could you repeat that? I'm sorry, Lexi was talking to people.
What's it called when you don't eat vegetables or fruit? You don't eat vegetables or meat
strictly carnivore, maybe? I don't know.
No, just only.
That's called not getting. That's called not getting the nutrients you need. Yes. Shh, quiet, please.
What if some of the cheese got moldy? Would you have to add like another event so then there's like bagels, cream cheese, and moldy cream cheese?
That could be something else. Yeah, that's a good question. If you did have another event, that means it would multiply by that many more times. So it would branch out. The tree diagram would branch out that much more. That's a great question. Anywhere. You can at the any grocery store. The most popular ones are Philadelphia regular and then the Philadelphia strawberry. There's strawberry right next to it, but there's going to be a whole bunch of different cream cheese. Go to just go to Breadco. See if you can just get coffee or something like that for mom, and then you get to see all the different kinds of it. There's a huge list. Good. All right, back together. So now that we're done associating it with real life, let's put some algebra into this and not just counting. Quiet. In literature class, which is language arts, each student chose one short story and one poem to read for homework. The students must choose from a list of 16 short stories and 8 poems. Algebra! There are 304 different combinations of short stories and poems possible. Find the number of poems on this list. What's the first thing we have to do?
Easy.
Yes.
You have to find event M.
Yes, we must identify the events. So event M. Event M. See, somebody I haven't heard from today. Cole. What would you want to be event M? Remember, event M is one of the things that happens that's not associated with numbers yet. The poems? I'm going to call that, you know what? Yeah, let's go with poems. Let's go with poems. So we'll go with poems. Even though poems is written second, we're going to call it event M. Sure. And the reason why I'm allowing that to happen is because think of this. Here we had 9 multiplied by 10. Which is 90. But what's 10 times 9? 90. It doesn't matter which one you call what. I like to keep it whatever order it's read, like whatever order you read it, that's how you'd keep it. But this one we're going to do it a little bit different just so you can see how it goes. And also so people from the previous class periods can see that you can do that. So poems, that is M. How many poems are there, which is the lowercase m? Yeah, Braden. H. There are H amount of poems. Since we already used the poems, what would event N be? Satrowski? Short stories. Short stories. Short stories. And how many short stories do they have to choose from? How many? 16. There are 16 short stories to choose from. Now I have to go ahead and substitute. I have my lowercase m multiplied by my lowercase n equals the number of choices. Let's substitute in. We have m, which is what? H. We have n, which is what?
16.
We have the number of choices, which is what? 304. And I'm going to rewrite that to being 16H because that's how we've done it all year with solving equations.
You put 306.
Please stop tapping or hitting your desk. That's next door. Okay, good. So 16H equals 304. So this is the inverse operations that you guys loved so much first quarter, but that was when you were just a baby, just getting out of 6th grade. Now you're almost an 8th grader. So we know how to do the inverse operations. And remember, inverse operations is the wording that we started using after we had gotten done with the undoing what's being done to the variable. What you got, Caitlin?
You would divide both sides by 16.
Beautiful. I have to divide both sides by 16 because the variable likes to be by itself. And I have h, and somebody who knows their math facts should know that one right away. Not because you practiced everything, multiplying up everything through 16, but because you know 16 times 2 is 32. 16 times 2 is 32. You were close. Yes?
Are we going to be able to use calculators on this?
No. There is no calculators permitted on this unit.
Did we finish the unit already?
Yep. It was done when we took the test. Well, it was a quiz, but it was a short unit, so it has the power of a quiz. H equals 19. Am I done? No. There are words in the question, so they need words in the answer. So I would write, there are 19 poems. Or to go all out. From which to choose. There are 19 poems from which to choose.
That's like a poem. There are 19 poems from which to choose.
Yep. It doesn't have to rhyme. Avery, did you write that down already?
Yeah.
Okay.
I'm a musical poet.
Stop hitting your desk. There are 19 poems from which to choose. Now, here's a situation that clears out any of the confusion from that homework question last night. It says a die is rolled twice, so it's the same one. How many possible outcomes are there? Okay? We are going to do this, and I want you to write this. On the back. So turn that over. I don't know why you wrote on the back. So we are going to do this on the back, and I'm going to zoom out a bit. So I'm going to do A. So here's A. I'm going to create a tree diagram, because on the homework you have to create a couple T diagrams. T diagrams. So I'm going to identify my events just so I don't make any silly mistakes. Clearly uppercase, clearly lowercase. Event M is die roll 1. And we know that there are 6 sides to a regular die. Event 2 is die roll 2. And there's still 6 sides. So I have my first roll. I'm going to have a point. How far does that go out? Make sure I don't get past my... Okay, right there. Let's go back to 50. I'm going to have my... I'm going to say the word roll. Then I want you to go 1, 2, 3, 4, 5, 6. Because it says that there are 6 ways, or 6 possibilities, 6 possible outcomes. And notice my view that I have, see that line on the right that's vertical? That's the end of my paper. So what are the possible outcomes of that roll? What are the possible outcomes of that roll? You have a regular die, yeah. Thank you. 1 through 6. 1, 2, 3, 4, 5, 6. There is event 1. Now I have event 2 that I see a lot of you wrote really small. That's unfortunate. I've already rolled a 1. What can happen from there? Webb. 6 options. 1, 2, 3, 4, 5, 6. And that could be 1, 2, 3, 4, 5, or 6. So I want you to write down the rest of these possibilities. Because 2 can also get 1, 2, 3, 4, 5, 6. I'm just doing a circle here just so I can keep it a little bit more organized. And I misjudged as well. I'll clean this up. So I'm going to count these while you guys are finishing up. If you're finished, that's fine. But if you're not finished, keep working. So I just circled 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36. And it should be 36. It should be 36 because we know that m times n is going to be 6 times 6, which equals 36. So the question, the first part asks us, how many possible are there? 36 possible outcomes. I'm going to put this here. I circle that. And it asks us for part B. What's the probability of rolling a 5 and then a 6? Ooh, probability. From Tuesday. Probability. Whoops. So I'm going to have you write a B. And you're going to write the probability. Be quiet. The probability, what were the two numbers? 5 and then a 6. Now think of this. When we went through probability on Tuesday, we had how many chances this has to happen over what? Do you remember the denominator was? Well, right, but what was the denominator, regardless of the problem for probability? No, not 36. It's not a number, it's a phrase. Over the possible outcomes. And look what we've been finding. We've been finding possible outcomes this whole time. See that? Possible outcomes. So we would look at this. The probability of rolling a 5 and then a 6. And I want it to look exactly like that, folks. A capital P with 5 and then 6 in parentheses below that P. So we have, I'll follow this trip down. we roll. We get a 5. Then we roll, and we get a 6. How many of those, at the very end of the final outcomes, how many of those did I circle in blue? Yeah. There's just one. So there's only one chance out of how many? 36. Out of 36. So it's 1 out of 36. Joe?
Why can't you roll a 6 and then a 5?
You can roll a 6 and a 5 and be the same thing. It would be 6 and then 5. It's still going to be 1 out of 36.
How would you get 1?
Do not leave without your homework.